Hi everyone, our new chapter Atomic Physics. In this case, I will explain Max Planck hypothesis and energy of photon. Firstly, what is the photon of definition? A photon is a particle of light. A photon has no mass and has no charge, but it has energy and momentum. Max Planck found that heat radiation is emitted and absorbed. After Max Planck, Albert Einstein explained the photoelectric effect of energy packets in light. The energy of photons range from high energy gamma rays and X-rays to low energy radio waves. All travel at the same speed, the speed of light. Okay, how can we find energy of the photon? We have to use this formula. Energy of photon is equal H multiplying F. And A means it is energy of photon. Unit is always joule. H means it is Planck constant. H is equal 6 times 62 multiplying 10 to the power minus 34 joules multiplying second. And F means it is frequency of the electromagnetic wave, frequency of photon, and unit is hertz. Okay, let's solve the exercise about energy of photon. This is first questions. For example, energy of photon is equal 81 multiplying 10 to the 2 joule, and Planck constant we know H is equal 6 times 62 times 10 to the power minus 34 joule multiplying second, and frequency of the resultant radiation, how much. And our formula, energy of photon is equal H multiplying F. Energy of photon we know it is 81 times 10 to the power 2 is equal, H is constant, it is Planck constant, 6 times 62 times 10 to the power minus 34, and frequency of radiation we don't know. And after calculate F is equal 81 times 10 to the 2 over and 6 times 62 times 10 to the power minus 34, and my result 1.2 times 10 to the 20 unit is hertz. Next example, laser pointer emits red light, and red light wavelength is equal 671 times 10 to the power minus 9 meters, and calculate the frequency and energy of red light. And firstly, we have to find frequency of the red light. Please remember this formula. C is equal wavelength multiplying frequency. C means speed of light. Always it is constant, 3 times 10 to the 8. And wavelength of the red light, we know it is 671 times 10 to the power minus 9, and frequency we don't know. And after calculate frequency, 3 times 10 to the 8 over 671 times 10 to the power minus 9, and my result 4.48 times 10 to the 14 hertz. This is my frequency. And energy of the red light, energy is equal H multiplying F. Again, H is constant, 6 times 62 times 10 to the power minus 34, and frequency we found 4.48 times 10 to the 14, and energy of the red light, my result 29.5 times 10 to the power minus 20 unit of energy, joule. Next example about photon energy. Photon of red light has wavelength of 7 times 10 to the power minus 7 meter, and another photon of violet light has wavelength of 4 times 10 to the power minus 7 meters. What are energies of these photons? And firstly, we have to find frequency of red light and violet light. Okay, I'm starting from red light. C is equal wavelength multiplying frequency. C is light of the speed, 3 times 10 to the 8, and wavelength of red light I gave 7 times 10 to the power minus 7, and frequency we don't know, and frequency is equal, after calculate my result, 0.4 times 10 to the 15 unit is hertz. Next, this is red light. Now violet light, C is equal HF 3 times 10 to the 8, wavelength multiplying. Wavelength of the violet light I gave 4 times 10 to the power minus 7, and frequency for violet light. After calculate my result, 0.75 times 10 to the 15 hertz. Now we know frequency of red light and frequency of violet light, and I can find energy of these photons. For energy of red light is equal HF, and H is constant, 6 times 62 10 to the power minus 34, and frequency of red light I found 0.4 times 10 to the 15, and my result 2.6 times 10 to the power minus 19 unit is joule. This is red light energy. Now energy of violet light. Same formula, HF, and H is constant, 6 times 62 times 10 to the power minus 34. Frequency of the violet light 0.75 times 10 to the 15, and after calculate my result 4.9 times 10 to the power minus 19 joule. This is for violet light energy. For today, that's all. See you next lesson.